the liquid that runs through the body's 95,000 kilometers, 60,000 miles, of blood vessels is an ever-moving supply train carrying a vast and relentless force of workers who labor non-stop. A single drop of blood holds more than 250 million separate cells, each with a job to do. Blood makes up about 7% of an average adult's body weight, a volume of between 3.5 and 5 liters, a mighty workforce indeed, which is being replenished at a rate of 3 million new cells every second. We need blood to nourish our bodies with proteins, glucose, salts and vitamins. Most of these are carried in plasma, which constitutes about 55% of blood. Plasma, a straw-colored fluid, is 95% water, with about as much salt as there is in seawater. That is why blood tastes salty. Also, plasma contains varying levels of nutrients and proteins. Plasma oils the works, ensuring that in a healthy body the blood flows freely. Most of blood's other 45% is made up of red blood cells, which outnumber the third constituent, white cells, by about 700 to 1. Red cells, or erythrocytes, are composed mainly of hemoglobin, a protein found in all animals, from insects and worms, to birds, fish and mammals. Their redness depends on how much oxygen this iron-charged pigment carries. An average blood cell holds some 350 million hemoglobin molecules, which are made from hem and globin in the bone marrow. The Red Army's job is to gather oxygen, which it does with great efficiency. Each hemoglobin molecule can carry 4 molecules of oxygen. Body tissues need oxygen when their cells burn glucose and other fuels to make energy. Carbon dioxide is a byproduct of this reaction. After delivering their oxygen, the hemoglobin molecules don't cruise back empty. The now not-so-red molecules transport carbon dioxide to the lungs, which expel it. All this hard labor finally wears out the red cells, which in a 4-month life complete some 300,000 circuits of the body's transport system. Their workforce comrades, the white cells, are in effect the body's defense force. And, like any efficient army, they are grouped into units. One destroys enemy invaders, such as harmful bacteria. Another group acts as scavengers, quietly removing dead cells. Other units pounce on poisons, nullifying their venom. The white cells are born in many places in the bone marrow, the lymph nodes, the thymus and the spleen. If you have ever wondered why we have tonsils, white blood cells are a good reason. Some of them come from there. In 1952, hematologist Jean Dosset discovered the substance in white blood cells that fights infection. Known as human leukocyte antigen, HLA, its components can be arranged in 150 million different ways. Other ingredients of our blood, the red and white corpuscles, the enzymes and platelets, show similar variations. The range is so vast that, apart from identical twins, no two human beings have the same blood patterns. Despite these variations, your blood is likely to resemble that of your relations. A specialist could take one drop, and tell you a considerable amount about your family history, your food preferences and perhaps even about where you live. If your diet lacks green vegetables, your blood will have less folic acid. People living in the rarefied atmosphere of high altitudes need more oxygen. For that reason their blood may have twice as many red corpuscles as that of people living beside the sea. At high altitudes, the air is cleaner. People breathing it don't need blood organisms that protect against diseases prevalent at sea level. That is why, when some people move from the mountains to the coast, they may suddenly become ill. A famous example is of Bolivian Indians who in the 1930s left their high plateau homelands to fight in lowland jungles of the Gran Chaco. Though impressive in physique, most of them soon sickened and died.